Hi students, today we are observing basics of organic chemistry. First, you observe the matter can divided into, we know the matter can be divided into elements and compounds and mixture, right? Okay, element, compound and mixture. Okay, so now if you observe element, compound, mixture. Okay, if you observe what is an element, depending upon the molecular arrangement or atoms arrangement, we are dividing the matter into element, compound, and mixture, right? If you take the compound, again, in the case of with respect to the organic chemistry, these compounds can be classified into organic compounds and inorganic compounds. Okay, first we classify the total compounds into organic compounds and inorganic compounds. Now, living organisms, okay, plants, animals, all comes under organic compounds. Whereas non-living organisms like minerals, gases, all those comes under inorganic compounds. Okay, so compounds can be classified into two kinds: organic compounds and inorganic compounds. Okay, under organic compounds, living organisms like plants and animals, and non-inorganic compounds, non-living organisms, and like minerals and gases. Okay, yeah. Now, organic compounds are the main foundation of all living organisms, right? So, organic compounds are the foundation of all living organisms. You see, in organic chemistry, this medicines, right? Because you observe any kind of tablet, okay, it contains all the organic compounds, okay. So, this can be mainly used in the field of medicine and pharmaceuticals, right? And this can also be used because we said that it is such as plastic, right? Minerals and gases, okay, such as plastics and synthetic fibers, okay, adhesives, and these comes under material science. So this organic chemistry can be can also be mainly present in uh, material science. Okay, next, energy source, fossil fuels, biofuels, and other energy sources are related to organic compounds, right? All energy sources. Next, environmental chemistry. Now you observe the study of environmental issues, including pollution, waste management, involves understanding the behavior of organic compounds in the environment, right? So, in order to study the environmental issues like pollution on the what are the gases we are getting from the we are getting any from any factory or something like that. So that all the things can be studied under organic chemistry. Okay. Yes, very good. Now, you observe here, here you can observe mainly like this, what do you say? Mainly this organic compounds when we talk, mainly it is a, these organic compounds are formed mainly by means of some vital force. So who stated this? By means of some vital, that is some magical or some a kind of magical force which will be was responsible to the for the formation of this organic compounds. Who said this? Bergili. He stated that organic compounds are existing in nature, no doubt, but how they are forming? By means of some vital force, like some magical or some any kind of force, some one kind of a magical force which is responsible for these organic compounds. Okay. Yes. Now you observe in organic compounds mainly carbon plays very important role. Why carbon is making very important role in the case of organic chemistry? If you observe, because of tetravalency. What is meant by valency? Valency is the number of electrons which are present in the outermost orbit, right? Yeah. Now tetravalency means because the outermost orbit is having 4 valence electrons. What is the valency of atomic number of carbon? Atomic number of carbon is 6, right? So what is its atomic electronic configuration? 2s2, 2p, 2 to 4, right? 4 to 6. Okay. So you observe that here this is the k orbital. This is L orbital, right? So k contains only s orbital and L contains s and p orbitals, right? Yeah. Now, so total here we are getting total 4 valence electron. That's why this carbon is having showing tetravalency. Okay, because of this tetravalency, uh, carbon tip mainly it can form 4 covalent bonds, right? Because it needs four more electrons to become stable. Yes or no? No doubt, carbon is having 4 valence electrons in the outermost orbit. It is ready to combine with 4 more electrons to become stable, right? To get the octet state, right? Okay, yeah. So here we this carbon forms 4 covalent bonds with other atoms. It is ready to form 4 covalent bonds, right? So which allows to create a diverse range of organic molecules. So it is because of this reason it is ready to create, it is ready to react with more number of organic molecules. Okay, these bonds can be, so it is forming a bond, right, with four any kind of 4 others, and it is also having carbon itself is having valency 4, and it is ready to form with 4 electrons of any kind of compound. Okay, like hydrogen, oxygen, nitrogen, like that. Okay, so it is ready to form. Now these bonds either can be single, double, or triple covalent bonds. Okay, single bond or double bond or triple bond. Okay, triple bond it is going to form. Now triple covalent bonds with other carbon atoms. So if it forms with carbon to carbon, a carbon is combining with carbon, then it can be called as it can be called as carbon with hydrogens. Say, let us take. This can be heteroatoms. These are heteroatoms. Okay. So now here you observe carbon atoms in organic compounds. In organic compounds often undergo hybridization. This is very important thing. Important word when you talk about organic chemistry under carbon. Okay. So carbon atoms, organic compounds often undergo hybridization. So we will see in detail what is a hybridization, that is sp3 and its shape sp2, sp, okay, all those in detail, because the carbon is executing this hybridization phenomenon, okay. And then another important thing is carbon has catenation. So carbon is most famous example for catenation. So it can form strong covalent bond with other carbon atoms. So it is going to form, okay, it is going to form strong covalent bond with other atoms, okay, other atoms, and allowing extensive chains, a very strong and big chains. Big chains are going to form, okay, by means of this branched structure. That's why this carbon is showing this property catenation. Because of that, carbon in organic compounds, we are giving preference to carbon. Okay, not any other elements, but first we are giving carbon. We are giving preference to carbon. Okay, got it? Yeah. So tetravalency, hybridization, and then catenation. Okay. Next, after that, so what he said, Berzelius stated that organic compounds are formed by means of some vital force, he stated. Next, that is Kolbe, he found that organic compounds could be synthesized from inorganic sources in the laboratory. So he made so many practical experiments and stated that so organic compounds can be Synthesized. So organic compounds can be synthesized, one organic one and organic two. So synthesized only from what? Inorganic compound. If you take any inorganic compound from inorganic compound, you are getting an organic compound, he stated. But Berzelius stated that organic compound, no doubt organic compounds are formed from organic compounds by means of some vital force. Okay, Berzelius stated that, but he stated by some inorganic compounds. Yes, understood. Next, so you see, he synthesis of acetic acid. He took an acetic acid and he synthesized it, and it can be formed in from inorganic sources in the laboratory. Okay, so the notion was rejected in 1828 by W. So what he said? So from means of inorganic compound, you are getting inorganic compound. He stated, right? So here he is taking, he synthesized an organic compound, urea, from an inorganic compound, ammonium cyanide. So from an inorganic compound, ammonium cyanide. This is inorganic compound. So from this inorganic compound, he synthesized an organic compound, right? He synthesized an urea, organic compound. Okay. Yes. Now, if you want to study in clear about these organic compounds, first you should know what is atomic orbital. So, atom consists of different atomic orbitals that contain no doubt electrons, right? So, valence electrons, you know. Valence electrons are the outermost electrons, right? Which are present in the outermost shell. Very good. Next, hybrid orbitals are formed when atomic orbital combine with hybrid orbitals are formed when one atomic orbital is combining with another atomic orbital, forming a new atomic orbital. That can be called as hybrid orbital. Got it? Now, urea. How the urea can be discovered? So urea was first synthesized by German chemist Wohler, right? We observed already. Wohler. Wohler, he found the organic urea. Okay, he formed organic urea. Okay, yes. Now you observe here, if you go with number of hybrid orbitals, let me tell you, before going to these, let me tell you about, first I'll go with the hybridization. So one atomic orbital is going to, yeah, you see now. Here you see now hybrid types of hybridization. What is hybridization? What do we know about by hybridization? Hybridization means one atomic orbital combines with other atomic orbital, forming a new atomic orbital. That can be called as hybridization, that process. Yeah. Now you observe types of hybridization. So sp hybridization. Here, if you talk about sp hybridization occurs. So sp, that is s orbital and p orbital, right? So one s orbital and one p orbital combine to form sp hybridization, resulting two sp hybrid orbitals, right? Okay. Say you are taking one red color powder and then one blue colored powder in one packet, two packets, red color and blue color. Say this packet is red color and this is blue color. Okay, I am mixing these two packets. Okay, if I mix these two packets, then no doubt you are getting that I have all packets of same size. I have covers. Okay, I have covers of same size, so I have to fill up all the things in those covers only. So what I do, I am taking one packet and another packet. So two packets, red and blue mixture red and blue mixed together and red and blue mixed together, right? So you are getting two red and blue colored packets, right? So in the same way, here you observe S and P we are taking. S is one orbital and P is another orbital. When one S orbital, one P orbital, these two combine together, forming two sp orbitals. Yes, understood? Two sp orbitals. These can be hybrid. Why these two are mixing? No? Mixing means hybrid. No? Okay. So common in linear molecules. So this kind of thing is common in linear molecules. Next, if you observe sp2 hybridization, this is what sp hybridization. Next, you observe sp2 hybridization. So sp2, right here, you are taking one s orbital and two p orbital because p2, yes, two p orbitals. So these two combine to form sp2 orbitals. Like you take one s orbital and two p orbitals. Two p orbitals. These two mixed together, you are getting sp2 one, another sp2. So how many orbitals you are getting? Three sp2 orbitals because we have taken one p, right? So sp2 and sp2. This is red color, okay, and two blue colored packets I took here. That is the meaning. One red color packet and two blue colored packets. So one red color packet and two blue colored packets mixing. So I have the same size of covers. That's why I can fill this total mixture into no doubt in three packets, right? Because all are having of the same size, right? So when you mix two things, that is here actually S and 2P. 2P means two blue color, that's all. But the quantity is same, no? In order to fill up this mixture, we require three, right? Yeah, very good. Now, in the same way, let us observe sp3 hybridization. Come on, you observe. So, can you guess? Pause video and guess it. What is the sp3 hybridization? Yes, very good. Yes, 1s and 3p, right? 1s and 3p. That means I took one red color packet powder. Okay. All packets are having same size for me. Okay. I have all the packets which are of same size. That is important. Okay. And 3P means three blue color packets, three blue color covers otherwise. Okay. I am mixing these two, sorry, 1S and 3P. So I am getting total how many? Can you guess? Yes. How many orbitals you are getting here? 1s orbital and 3p orbitals combined. So totally, how many are getting? Come on, think it. How many you can get? Yes. So now here you are getting 3p orbitals and one sp3, one s orbital. Otherwise, you see here we took sp3 hybridization, no? Yeah. You see, results in 4 sp3, right? 4 sp3 orbital, sp3, sp3 and sp3. Yes. So 4 sp3 orbitals which are tetrahedral molecules. Tetra means 4, right? Okay. Now you observe before case. In before case, let me take you that slide. Yeah. You see here. This is 3, no? 3 sp2. That's why triagonal planar or triagonal pyramidal molecules. This is linear because this is having only one and one, right? That's why it should be linear one. Linear, triangular, tetrahedral. Okay? Tetrahedral. Like this we are getting. Understood? Yes. Now I am taking sp3d hybridization. You see this. This is the new thing. sp3d also. So I took S and P3 and then D. So here this is red color powder and 3 blue color powders, and this is D, 1 yellow color powder. Yes, I am mixing all these. 1 red color, 3 blue color, 1 yellow. So how many I am going to get? Yes, triagonal bipyramidal. Yes, because sp3, S and sp3 triagonal. S and sp becomes triagonal bipyramidal. Okay, 1d orbital. So results in how many orbitals? 1, 2, 3, 4, 5 packets, right? Because this is S1, P3 and this is 5. Total 5. 1 plus 3, 4, 4 plus 1, 5. So total 5 orbitals we are getting. 5 hybrid orbitals we are getting. So if you observe the shape of that is triagonal bipyramidal. Understood? Yes. Let us move to the next one. That is sp3d2 I am taking. How do you do this one? Yes, P3 and D2, right? So, 1 red color powder packet, 3 blue color packets and 2 yellow color packets. So, totally how many you are getting? 6, right? Yes. So, 3 p orbitals and combine to form, what is that? S6 sp3. So total how many? 1, 1 plus 3, 4, 4 plus 2, sp3d2 hybridization, right? sp3d2 hybridization. So occurs 1 s orbital, 3 p orbitals and 2 d orbitals combined. Results in 6, right? So 6, total 6 sp3d2 orbitals. So the shape, if you observe the shape of that will be octahedral of octahedral molecule. Okay, we are getting octahedral molecule. Understood? Yes. Now you observe how to determine the hybridization. So in order to determine, before going to this, let me go with some examples. Yeah. So here you observe, yeah, we studied all this one. S orbital plus p orbital. You see, s orbital plus p orbital. You are getting hybrid orbital. Yes, hybrid orbital. So this is having small energy and this is having large energy. When these two combine together to form hybrid orbital. Understood? Hybrid orbital. Very good. Okay. So in the same way, so why we are studying this hybridization? Molecular geometry. In order to know the molecular geometry of any compound or bonding of orbitals can also be determined by using this hybridization. Okay, mixture of atomic orbitals. That is when different orbitals of same or nearly same energy. So those two should be same energy levels. You should not take S and D or something like that. S orbital and D orbital. Okay, together to form new hybrid orbitals. Okay. So why they are going to combine? A atom react with B atom, Sp, Ss, right? So like this, they are going to combine. Okay. Next, Sp hybridization. S plus P, Sp hybridization, Sp hybridization. Okay. S and P, these two combine Sp hybridization. Okay. SSP, SSP. Now you observe here, is there any hybridization? No. Number of hybrid orbitals equal to number of intermixing orbitals. Number of hybrid orbitals equal to number of intermixing orbitals. So if you observe in BeH2, we can generate two equivalent orbitals by combining two s orbitals. You combine two s orbitals, beryllium and any one of three degenerate 2p orbitals. Okay. By taking the sum and difference of these two orbitals, 2s and 2p2, we produce new orbitals with major and minor lobe. Okay, so those can be oriented along z axis or depending upon the orbital, they are going to get the shape. Yes. Okay. So NH3, N undergoes sp3 hybridization even after having a fully filled. Yeah, we will study these in detail in the next video. Okay. Okay then. Bye. Thank you.